Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about closed loop control systems. This is linear control systems, lecture series on linear control systems, lecture number 4. So our topic's name, closed loop control systems. Overview. What is the overview? What is closed loop control systems? Basic block diagram representation of closed loop control systems. Working loop of closed loop control systems. Advantage of closed loop control systems. Disadvantage of closed loop control systems. Example of closed loop control systems. Examples of real-life closed loop control systems and comparison between open loop and closed loop control systems and conclusion. These are all our overview. So our topics, closed loop control systems. What is closed loop control systems? It is that closed loop control technique in which a process variable in a process plant is maintained at the desired value by adjusting fuel or energy flow to the plant according to the feedback information received from the plant about the actual value of the control variable and its deviation from desired value. So for closed loop control systems, feedback information presence. This is the very important sentence. So very important part, feedback information and received from the plant about the actual value of the control variable and its deviation from the desired value. This is the closed loop control systems. Closed loop control systems, two types, mainly manual closed loop control systems and automatic closed loop control systems. So this is the block diagram for closed loop control systems. So first, this is reference input. This reference input may be step, ramp, parabolic, impulse, sinusoidal, any type of input you can apply. This is also called set point. And this is the comparator or summing point. And this is the error signal. And this error signal equivalent to or equals to reference input signal minus feedback signal. And this is the amplifier, and amplifier output signal actually input of the controller, and controller output signal input of the plant or process. So controller output signal, this is the controller output signal, and this signal input of the plant or process. This is the control systems. And after operation, the controlled output, this is the controlled output, and this is the feedback path. This feedback may be positive or may be negative, and controlled output divided by controlled reference input ratio is called efficiency, and control system language, this two ratio is called transfer function if all the conditions, all the initial conditions are zeros. So this is the block diagram for closed loop control systems. And what is the practical examples of the closed loop control systems? Automatic electrical iron, water level control, servo voltage stabilizer, and air conditioner, cooling system in car, missile launched and auto tracked by radar. These are all closed loop control systems examples. So first definition, what is manual closed loop control systems? What is manual closed loop control systems? It is that closed loop control technique in which a process variable in a process plant is maintained at the desired value by adjusting fuel or energy flow to the plant with the help of an experienced operator according to the deviation of the process variable from desired value. So this is the manual closed loop control systems. In this case, this is the experience controlled by experienced operator. That's why this type of control system is called manual control systems. This type of control system is called, and this is manual control systems. And what is the example? Manual closed loop control system of temperature of room by adjusting steam flow by an operator. That means room temperature control by an operator or by the operator. This is the example of the manual closed loop control systems. What is the block diagram? Cold supplied by the experienced operator according to deviation of room temperature from the desired value. Suppose our required temperature 25 degree centigrade. Suppose our required temperature 25 degree centigrade and cold supplied by the experienced operator. That's why this is manual, and this is the desired value amount, the desired value. Then this coal, this is the furnace section or heating systems. After burning, this is the boiler, and boiler controlled by water, boiler level controlled by water, and boiler steam storage unit. This is the steam storage unit, and this steam control the room temperature. This steam control the room temperature, and this is the room required temperature 25 degrees suppose. So room being heated, and if telephone operator sending information about the actual temperature of the room, this is the telephone operator sending information about the actual temperature of the room, because this temperature, required temperature, if 25 degree, this is 25 degree temperature, or below 25 degree temperature, or above 25 degree centigrade temperature, and then collect this information by experienced operator and sending the information again this room. And this section, exhaust steam, exhaust 5, this is the exhaust system. So this is the closed loop systems, because this information, this is the closed, this is the feedback path. This is the feedback path. That's why this is closed loop systems, and room temperature and controlled by manually or controlled by man. That's why this experience operator also, this is experience of this. That's why this type of control system is called manual control systems. Then what is automatic closed loop control systems? What is automatic closed loop control systems? It is that closed loop control technique in which a process variable in a process plant is maintained at the desired value by automatically adjusting the fuel or energy flow to the plant without any human who helps. So in this case, no human required, without any human help. That's why this type of control system is called automatic control systems. Suppose our example, automatic generation control, automatic power generation control, one example. And this is the exact block diagram for automatic generation control. And this section, input section, this section, input section, or set point or desired value. And this is the comparator or summing point, comparator or summing point. And this is the control unit. This is actual actuator output signal control the signal converter, and signal converter output control automatically or manually. In this case, automatic control system. That's why we can use auto systems, automatic section only, automatic section only. And this signal control the final control element, and final control output response control the process or plant. And after operation, we get the output. This is the controlled output, and this control output feedback is feedback, and this feedback may be positive, may be negative, may be positive, may be negative, and this is the detector and amplifier unit by sensor. So this is the automatic closed loop general block diagram, automatic closed loop block diagram representation of automatic closed loop control systems. Closed loop control systems, another definition. In closed loop control systems, the plant output is feedback to the input, plant output feedback to the input. So in closed loop systems, the plant output depends on the control action of the system, and the control action is dependent of the desired output. So this is the closed loop system definition. And this is the block diagram. This is reference input or set point, and this is the comparator. And this signal, error signal means reference input minus feedback signal. This is also called ET signal, error signal also called ET. ET equals to reference RT minus feedback signal, So amplifier output response control the controller section, and controller output control the plant or process, and after operation, this plant or process output. Generally, this is the controlled output or final output. This is the final output, and this is the feedback path, and this feedback may be positive or negative. In this case, reference input may be step, ramp, parabolic, impulse, sinusoidal, any type of input you can apply it. And this is the feedback elements, generally sensor. And closed loop control system, another definition. In this type of control system is one in which the plant output is dependent on input, and also the controlling action or reference input is dependent of the output of the system. So this is the another definition for closed loop control systems. Closed loop control systems are also known as feedback control systems. In closed loop control systems, the control action is dependent on the desired output. In closed loop control systems, having one or more feedback paths or loops between its output and input. This is also very important sentence. One or more feedback paths or loops between its output and input. In this type of control systems, the output is compared with the reference input, and error signal is produced. The error signal is fed to the controller to reduce the error, and desired output is obtained. So this is a very important point. The closed loop system generates the error signal, which is the difference between reference input and feedback signal, already discussed. Error signal means reference input RT minus feedback signals. And construction is complex compared to open loop systems. Reliability is high. Closed loop systems, for closed loop systems, reliability is high. This is the block diagram for closed loop control systems. Stability is less. Optimization is possible. Response is slow compared to open loop systems. Calibration is easy. System disturbance is not affected. The closed loop systems monitors the output and compare it to the input. If an error and detected, the system corrects the output and hence corrects the effects of the disturbance. So this is our important features of the closed loop systems. Working loop of a closed loop control systems. This is the block diagram of the closed loop control systems already discussed. This is reference input. This is the error detector. This is the error signal. Error signal equals to reference input minus feedback signal. Error equals to reference input minus feedback signal. This is the controller section. Controller output is also called actuating signal. This actuating signal, ultimate input of the plant, and after operation of the plant, we get the desired output. And this output, this is the feedback path, and this or feedback element. So this feedback may be positive, may be negative. In general, we can use negative feedback. The basic block diagram of the closed loop control system. This is the basic block diagram of the closed loop control systems. For closed loop control systems, output is feedback. This is the output, and output is feedback. Output is feedback to the input. Output is feedback to the input. Control action is dependent on the desired output. The error detector generates an error signal. This error signal actually difference between the input and the feedback signals. The feedback signal is obtained from the feedback elements, which is connected with the output of the overall systems. This error signal is input to the controller. This error signal is input to the controller. The controller section generates an actuating signal. The controller signal generates an actuating signal, which is controls the plant or process. The output of the plant is adjusted automatically, and we get the desired output. This is the output, desired output. The closed loop control systems are also called the automatic control systems. So what is the advantage of the closed loop control systems? Closed loop control systems are more reliable. Closed loop control systems are faster. A number of variables can be handled simultaneously. In closed loop control systems, optimization is possible. There are facilities of automatic in these systems. Proper calibration is possible. Closed loop control systems have high bandwidth, that is high operation frequency zone. In these systems, the errors are modified. Another advantage, by increasing the feedback loop gain, the sensitivity of the closed loop systems for parameters variations is made small. And this system reduces the effect of noise and disturbance on the system performance. Accuracy is accurate because of feedback path. Accuracy of the closed loop control systems are very high due to correction of any arising error by feedback. There is reduced effect of nonlinearities in these systems. Noise reduction ability, they clear out the errors between input and output signals. So what is the disadvantage of the closed loop control systems? First point, closed loop control systems are expensive. Closed loop control system maintenance are difficult. The closed loop control system installation are complicated. Closed loop control systems are may be unstable. Closed loop control systems are complicated in design. Feedback can be harmful to stability if it is not properly applied. Closed loop systems are more costlier than open loop systems because of additional components required for feedback. In the closed loop systems, the feedback may lead to oscillatory response. The feedback effect decreases the overall gain of the systems. Stability is the most important problem in the closed loop systems, and additional concerns is required to design a stable closed loop systems. What is the example of the closed loop control systems? Example of the closed loop control systems are air conditioners, temperature control systems, scent pressure control systems, refrigerators, thermostat heater, sun investigator solar systems, voltage stabilizer, missile launched auto engine, and inverter AC, automatic toaster, turbine, water control systems at power station. Examples of real-life closed-loop control systems. The real-life closed-loop control systems are temperature control systems, house thermostat, temperature control system. This is the real-life examples. Vehicles control systems. Both the examples are feedback and closed-loop system because they make automatic adjustment. Automatic electric iron working principles. This is the block diagram for automatic electric iron. This is also closed loop systems examples. So what is the input? Reference input. This is the desired temperature. This is the desired temperature. And this is the temperature comparator or summing point. This is the temperature controller, regulator, and this is the error signal equivalent to reference input minus feedback, and error signal input of the switch, and switch output control the heater, and this 2 unit is called controller. After controlling the signal, the plant or process operate. This is the iron in this section, and after operation, the control output, we get the control output. This is the iron temperature, and this is the feedback path. Feedback may be positive, may be negative. Figure shows the closed loop control systems of an automatic iron. An automatic iron regulates the temperature of iron in such a way that the temperature for a specific cloth remains in a specified range. So this is the automatic electric iron working principle or block diagram operation. Control systems for moving on a desired road. So this is our practical example. This is the desired direction. T is the reference input. This is our I. This is our I. I control and control the brain. This is the controller section. Brain sending the information. So this information signal actually important signal because this signal control the process or plant here. Legs in this section, plant or process, and this legs controlled and generate the output signal. This is the actual direction, and this is the feedback signal. This is the feedback signal when I opens. When I opens, this is called closed loop systems. When I closed, this is called open loop systems because when I closed, this path absent. That's why this signal is called open loop. When I open, the signal is called closed loop. In anybody moves away from a desired road with open eyes, it is an example of the closed loop system as shown in figure. It will be an open loop systems if eyes are closed. Feedback with unity feedback. This is the feedbacks example, and second figure, unity feedback examples. Unity feedback examples. Examples of the temperature control systems. This is the another example, temperature control system. The closed loop control system example, temperature control systems. This is the block diagram. Reference input, this is comparator, and it is error signal, valve, this section controller, and valve output signal is also called the control signals. Control signals input of the system steam flow, and steam flow output is also control the water tank. This is actually plant or process, and steam flow, this section is called actuator, and actuator output signal is called actuator signal, and this is the achieved temperature or controlled output, and this path feedback path. Feedback may be positive, may be negative. So temperature control circuit, this is the block diagram for temperature control. And this section, what is the error signal? Error signal equals to this signal error equals to RT minus CT. RT minus feedback signal. RT minus feedback signals. This is the feedback control systems. Difference between open loop and closed loop control system. What is the basic difference open loop control systems and closed loop control systems? Open loop control system, first point. In open loop systems, the system's output always is free from their input. For closed loop systems, the reference output depends on their input. And second point, this type of is called the non-feedback systems. Open loop system is also called non-feedback systems, and closed loop systems always feedback type systems. This is second difference. And third difference, open loop system, this is third point. In these systems, only two components required, that is control and control process. And control loops, closed loop systems, for closed loop systems requires various components like an reference input, amplifier, controller, feedback, control processor. So closed loop systems required components. These are input, amplifier, controller, feedback, control processor. Another example for open loops, another difference. The structure of the open loop system is very simple because minimum number of essentials are used. For closed loop, in this type of the systems, the construction is very complex. And next point, for open loop, the open loop system is not reliable. And for closed loop, the closed loop system is reliable. Another difference, the accuracy of the system is less for open loop system. The accuracy of the system is high. This is for closed loop systems. For open loop systems, it is more stable. For closed loop systems less stable. For open loop systems, this type of system is not optimized. And for closed loop system is optimized. Open loop systems, another point, the response is faster. For closed loop systems, in this type or in this system, the response is slow. Another point, for open loop systems, the calibration is difficult. For closed loop systems, the calibration is not difficult. And next point, for open loop systems, in this case, the disturbance is affected with output. For closed loop systems, in this case, the disturbance is not affected with output. And next point, open loop systems, example, traffic light, automatic washing machine, etc. And for closed loop example of the closed loop system, temperature controller, air conditioner, automatic toaster, water level controller, home heating system, DC motor speed control, and missile launching systems. These are all closed loop examples. So thank you. This is our closed loop control systems.